From orbit, the Earth looks peaceful. A blue sphere wrapped in white spirals, drifting through the void. But peace is an illusion. Beneath the surface, beneath the waves, beneath the pressure of entire oceans, lies the true machinery of our digital civilization. We imagine the internet as wireless, signals bouncing through the air, data floating in the cloud. But the cloud is a metaphor, a comforting lie. The real internet is physical. It is heavy. It is industrial. It is buried in the darkest places on Earth. Every message you send across the world, every video call, every bank transaction, every late-night meme, travels through cables lying silently on the ocean floor. Invisible, uncelebrated, essential. This is the story of those cables. The story of the threads that bind continents. The story of how light travels through darkness to keep the world connected. Long before fiber optics, before lasers, before the word internet existed, there was a dream. What if two continents could speak? In 1858, engineers attempted the impossible, laying a telegraph cable across the Atlantic. It took multiple failed attempts, storms, broken lines, and political pressure. But eventually, a faint signal arrived. 2 words per minute, barely readable. But it worked. For the first time in human history, information traveled across an ocean faster than a ship. The cable didn't last long, voltage issues burned it out. But the idea survived. And it grew. Copper telegraph lines became coaxial cables. Coaxial cables became early telephone lines. And then, in the late 20th century, came the revolution. Fiber optics, glass threads that could carry light itself. Humanity didn't just connect continents. We stitched the planet together. A modern undersea cable is a paradox. Fragile at its core, armored like a beast on the outside. Imagine slicing one open. The outer layer, polyethylene, a tough plastic skin. Beneath it, steel wires, wound like the muscles of a mechanical serpent. Then copper, carrying electrical power across thousands of kilometers. Inside that, water-blocking gel, absorbing shock and pressure. And at the very center, a strand of glass thinner than a human hair. This is where the magic happens. Lasers fire pulses of light into these fibers. Each pulse is a bit, a 1 or a 0. Billions of pulses per second. Billions of decisions. Billions of tiny flashes carrying the weight of human communication. But one fiber isn't enough. So engineers discovered a trick. DWDM, dense wavelength division multiplexing. Instead of sending one color of light, they send dozens. Each color carries its own stream of data. It's like turning a single road into 100 invisible highways. A single cable can carry millions of simultaneous video calls. Entire nations depend on these threads of glass. Inside this armored serpent lies a river of photons. A river that never sleeps. A river that carries the heartbeat of the modern world. Before a cable touches the ocean, it begins life in a factory the size of a shipyard. Engineers create it in continuous lengths, kilometers at a time, winding it into massive rotating tanks. These tanks look like giant cauldrons, slowly spinning, storing the future. Then comes the ship, a cable-laying vessel, part factory, part laboratory, part surgical instrument. Its mission, to draw a line across the Earth. The ship moves slowly, guided by GPS with millimeter precision. The cable feeds out from the tank, slipping into the water like a ribbon of light. It sinks and sinks until it reaches the ocean floor. Near coastlines, the cable must be buried. A robotic plow digs a narrow trench, lays the cable inside, and seals it with sand. This protects it from anchors, fishing trawlers, and storms. Farther out, in the deep ocean, the cable simply rests. There is no need to bury it. Down there, the world is quiet, still, timeless. Laying a cable is like drawing a line across the planet with a pencil made of glass. A line that will carry the world's conversations for decades. The deep ocean is a place of extremes, a place where sunlight never arrives, a place where pressure can crush steel, a place where life moves slowly, cautiously, silently. And yet, this is where the internet lives. Cables lie on the seabed like sleeping dragons. A crab scuttles over one. A fish glides past. The cable doesn't move. It doesn't glow. It simply exists, a quiet artery of global communication. There are myths. Sharks bite the cables. Whales get tangled in them. Reality is far less dramatic. Most damage comes from us. Anchors, fishing nets, dredging, and occasionally earthquakes. But for the most part, the cables endure. They are built to survive the ocean's indifference. They are built to last. Inside each cable, light travels in silence. But even light needs help. Every 80 kilometers, the signal begins to fade. So along the cable are small, sealed devices called repeaters. Repeaters are the heartbeat of the system. They amplify the signal, giving photons the strength to continue their journey. Each repeater is powered through the copper layer of a cable, a thin electrical lifeline running thousands of kilometers. Inside a repeater, lasers and amplifiers work in perfect harmony. They don't decode the data. They don't understand it. They simply strengthen it, like a whisper passed from one messenger to the next. Routing is equally elegant. Your message doesn't wander. It takes the fastest path. A route shaped by geography, politics, economics, and physics. Latency isn't just a number. It's the speed of light in glass, a physical limit, a reminder that even in the digital world, we are bound by the laws of nature. Every message you send is a photon sprinting through darkness, a tiny traveler crossing oceans in milliseconds. For all their strength, cables can break. And when they do, the world feels it. A fishing trawler drags an anchor. A storm shifts the seabed. An earthquake snaps a line. A ship drops anchor in the wrong place. Suddenly, a region goes dark. Traffic reroutes. Latency spikes. Engineers scramble. How do they fix it? First, they locate the break using signal timing, a digital echo that reveals the distance to the fault. Then, a repair ship is dispatched. It lowers a grappling hook into the ocean, snags the cable, and pulls it to the surface. The damaged section is cut out. A new piece is spliced in. The cable is sealed, tested, and lowered back into the deep. Is delicate work. Slow work. Work done in storms, in waves, in isolation. The world's connectivity hangs on threads thinner than a human hair. And yet, those threads hold. The story doesn't end here. In fact, it's just beginning. New cables are being built every year to support AI, cloud computing, and the rising tide of global data. Researchers are developing hollow core fibers, where light travels through air instead of glass, reducing latency even further. Quantum communication promises cables that can detect tampering instantly. A new era of secure global links. And as the world becomes more connected, the ocean floor grows brighter, not with light we can see, but with the silent pulse of information. The internet is not in the cloud. It is in the ocean, a living, breathing network of light, woven through the darkest places on Earth. So the next time you send a message across the world, remember the journey it takes. Through glass, through darkness, through oceans. Remember the invisible layers beneath your feet, the threads that bind continents, the rivers of light that carry our stories. Thanks for watching, and I'll see you in the next chapter of this digital adventure.